Our previous discussion on the range of optimality is referring to a single change in the objective function coefficient. But what if there will be multiple changes simultaneously in objective function coefficient? Actually, we have one rule called 100% rule, which can be used to determine whether we still have the same optimal solution if we have multiple changes in the objective function coefficients. If there are multiple changes in the objective function coefficient, we are going to first compute for the percentage change for each individual decision variables. For example, we have decision variable j, and we are going to compute for rj equal to delta cj over ij if delta cj larger or equal 0. Delta cj means the change of the coefficient from the current value to a higher value. Over ij is the allowable increase. If delta cj less than 0, it means we decrease from the current coefficient value to a lower value. We are going to use negative delta cj divided by dj. dj is the allowable decrease. If we have multiple changes in the coefficients, we are going to sum all those percentage change. In this case, we are going to sum all ij together, and that will be equal to the sum of delta cj over ij or dj. As long as the sum of the percentages is less or equal 100%, we can guarantee that we still have the same optimal solution, even we have multiple changes in the objective function coefficients. Of course, if we have a percentage change in total larger than 100%, we might still have the same optimal solution. But right now, we cannot guarantee that we still have the same optimal solution. So my suggestion is you need to resolve the entire problem by rerun the Excel solver. Let's look at this example. In this example, we have x1 with a coefficient of 350, x2 with a coefficient of 300. Our current optimal solution is 122 for x1 and 78 for x2. And from this table, we can also learn that the allowable increase for x1 coefficient is 100, allowable decrease is 50. For x2, we have allowable increase 50, allowable decrease 60.67. Suppose we have changed the coefficient of x1 from 350 to 380, and we change the coefficient of x2 from 300 to 266.66. In this case, we have increased the value of cx1 from 350 to 380. So the change delta cj for cx1 will be 380 minus 350 over 100. 100 is the allowable increase for x1. For x2, we have decreased the value from 300 to 266. So we can use 266.66 minus 300 over the allowable decrease. In this case, it will be 66.66 for x2. We sum these two percentages together, we get 80%. And we know 80% is less than 100%, so we have the same optimal solution, 122 for x1 and 78 for x2. But what if we change the cx1 from 350 to 410 and cx2 from 300 to 266? In this case, we have increased value from 350 to 410. So the difference will be 410 minus 350 over allowable increase of 100 plus 260.66 minus 300 over the allowable decrease of 66.66. In this case, we get a total percentage change of 110. So it's more than 100%. So we have to resolve the problem, although we might still have the same optimal solution, but we do not know. So we should resolve the problem to get a new optimal solution. Thank you. you.